through here on activity number 4, geometric series. First page here, there actually isn't anything to write. It's more just reading through it and understanding what the process is. Here we have the same table that we had before. We have additional number of sick people, and it's tripling here every day. So on day 1, there was 1 sick person. On day 2, there were 3. On day 3, there were 9. On day 4, there were 27, multiplying by 3 every time. So we can write that exponential. So we notice that this is a geometric sequence. To find the total number of sick people, though, because this is an additional amount, we need to add these numbers all together. So we're just using the exponent here. And then when we get into 1a, this is going to show us how we can derive the formula to find the sum no matter how many days we want to get out to. So the sum, if we write it out, s sub n equals 1 plus 3 plus 3 squared plus 3 to the third plus 3 to the fourth plus all those other numbers plus our last term is 3 to the n minus 1. Realize here we cannot use our arithmetic series formula because if I were to add, say if I were to add 81 and 1 and add 27 and 3, I do not get the same number. So if I tried to add up the first 5 terms, that's not going to work. So we realize that's not one formula that's going to work here, so we need a new one. So here's how we get the new one. What we're going to do in step 2 is we multiply this sum. So we're going to multiply this equation by 3 on both sides. So we get 3 times s sub n, and then 3 times this whole sum of 1 plus 3 squared, and so on. Then we distribute the 3 into this group, and we get 3 times 1, 3 times 3, 3 times 3 squared. So really what happens is each exponent just gets bumped up 1. And then the reason we did that is because now when we subtract this statement in step 3 and this statement in step 1, a lot of these terms are going to line up and simplify out to be 0. So I'm going to take my equation in step 3 and subtract off the equation in step 1. And that's what we see here in step 4. And as we simplify, we get 3s sub n minus 1s sub n. So that's on my left-hand side. And on the right-hand side, all of these in the middle simplify out to be 0. So I have 3 to the n minus 1. So there's our simplified, reduced statement in step number 5. And then what we are going to do here is we could put these together. We have 3 s sub n minus 1 s sub n. So I realize, yes, that's 2 s sub n's. But to understand how the formula is going to work, I'm actually going to factor out a GCF of s sub n and leave this as 3 minus 1. So 3 minus 1 times s sub n, and then the right-hand side stays the same. And then if I'm trying to solve for s sub n, I need to get rid of this 3 minus 1. So I'm going to divide by 3 minus 1. And that's how we see our final formula here. So that's just reading through those steps. We're going to have to generate those steps again on our own a couple of times as we go through this activity. So what do variables represent? So on the next page, it says define what n means in the context of the situation. So in this case, n is the number of days. It's how many terms are being added. And then in part C, it says explain why the strategy in part A, multiplying by 3, is going to work. And how do we create that new series? And what happens is, because 3 is the constant multiplier, when we multiply by 3, we line up all those values that are going to subtract to 0. And we only are left with those 2 terms that are left. So that's why we picked this 3 to multiply by here. So all of these lined up, and I ended up with a bunch of zeros in the middle of those. And then part D, use the formula in part A to calculate the total number of sick people at the end of day 6. So here's our formula that we're going to use, 3 to the n minus 1 over 3 minus 1. And n stands for the number of days. So now I just have to plug in 6 for n. If you're going to use your calculator, make sure you put this in parentheses and this 3 minus 1 in parentheses. And we end up with 364, which is the same number that we had back on that last activity. All right, part E on the bottom of the page. Now we're going to use the same steps, but our sequence is 1 and then 5 and then 5 squared, 5 to the third, 5 to the fourth, and so on. So if I want to find the sum, We write it out just by adding the terms. Here, we realize our common ratio is 5. We're multiplying by 5 to get the next term in that series in the sum. So my step here, when what I'm going to multiply by isn't 3 this time, it's going to be a 5. So we multiply by 5 on the left side and on the right side. Then we distribute. So this 5 goes into all of those, increases the exponent by 1. Then we're going to subtract. So I'm subtracting my statement in step 3 minus my statement that's in step 1. So there's my step 3, there's my step 1. I tried to kind of move them over so we can see we're going to get a bunch of zeros here as we subtract. So I'm going to be left with 5 to the n minus 1 on the right hand side. And on the left hand side, I've got 5 s sub n minus s sub n. We're going to factor just like we did on the previous one. So I've got 5 and a 1, so 5 minus 1 times s sub n. Right side stays the same. I'm solving for s sub n, so then we're going to divide by this 5 minus 1, which I realize is 4, but again, I want you to see what the pattern is and kind of what's going on with this particular number. So there would be the sum. So say I wanted the sum of the first 30 terms in this sequence, I'd plug in 30 for n, and it's going to be a really, really large number. All right, then over on the next page, part F, we make a general. So now I've got my first term is 1, and now my next term is r, and then r squared, and then r to the third. So in the first example, r was 3. In the second example, r was 5, but now I'm just calling it r. So what are we going to multiply by? Well, this time we're going to multiply by r, because that's what our common ratio is. Step 3, we're going to multiply this out. So we distribute, end up with our new statement. Now we're going to subtract. As we subtract, we're going to subtract our statement in step 3 from our statement in step 1. So over on this side, I get r times s sub n minus s sub n. So there's this particular left side. And then over here, all of these are going to simplify out in the middle. I'm left with r to the n minus 1. This particular case is why we didn't put those together before. I have r times s sub n minus 1 s sub n. So I have r minus 1 times s sub n. Right side still stays the same. And then to get rid of the r minus 1, we're going to divide. So here is our formula. You will not have to derive this formula. You will not have to use these steps. You'll have to know how to use this formula, when to use it, and what the variables are going to represent as we're trying to solve. So we don't really have to worry about any of those steps anymore. We're now going to focus on how do we use this formula. So in part G, let's talk about the formula. How many terms are being added, and how does that appear in the formula? So there are n terms that are being added, and n is the exponent that's on that common ratio r in the formula. So there's the number of terms, and r is my ratio. What you'll notice here is in this formula, I do not need the first term and last term. If my first term is 1, this is the formula we can use. And we're going to see in a little bit that we're actually going to have something else that we're going to have to include if the first term isn't 1. All right, so part H, use that formula to find the sum of the first 7 terms of 1, 8, 64, 512, and so on. So what do I need? There's our formula. I need to know what is the r and what is the n. So in this case, the multiplier is 8. And I want to know the first 7 terms. So the n number is going to be 7. So 8 to the 7 minus 1 over 8 minus 1. Make sure that you use parentheses around those when you type that in the calculator. And we end up with 299,593. All right, but what happens if the first term isn't 1? So as we look at number 2, the sums and formulas that we work with so far apply to sequences with an initial term of 1. Now we're going to look at sums where the initial term is not 1. So suppose an epidemic begins with 2 infected people on day 1 instead of the 1. So here we have 2, and then times 3, times 3, times 3, times 3, and so on. Without doing any shortcut formulas, find the total number of people infected. So that just means no shortcuts, just add those together. So we add those together, and we end up with 728. How does that number compare to the answer that we got in 1D? So as I flip back to 1D, I had 364. So how does that compare? This number is twice as big. Twice as big, I started with 2 times more people at the beginning. All right, we'll see if that rings true as we keep going through. All right, so step C is actually just reading this again. So we write out the sum. We had 2, and then 2 times 3, and then 2 times 3 squared, and 2 times 3 to the third, and so on. So there's our sum. The first step here is actually factoring out the 2. As we notice, there's a 2 in each one of the terms, so we can factor the 2 out. And now I have this sum of 1 plus 3 squared plus 3 to the third, and so on. And if I remember, this statement here has a formula for it already. We just found it back on the very first part of the activity. So this part in parentheses is really this formula right here. So all that we're doing is we're just taking out that particular that sum written out as a plus, 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 and we're going to use our formula that we found back on number 1. So use this formula to determine the total number of sick people at the end of day 6. How does it compare? So now I've got my 2, and I want to know after 6 days. So I'm going to put 6 in for n, and we go ahead and multiply 3 to the 6th minus 1 over 3 minus 1. I got 364 for that. 2 times that number is now my 728 that we found before. All right, using those same steps, now we're going to make it general. So instead of having a 2 here, we have g sub 1, whatever that first term is. And then we multiply by r again, so r squared, multiply by r again, so r to the third. So to find the sum, put them all together. Instead of factoring out a 2, I don't have a 2 in this case, but I do have a g sub 1 in all of these terms. So I factor out the g sub 1. And then as I look at this, 1 plus r squared plus r to the third, that looks a lot like this right here. So now I understand that that's the formula that I can put in place. So this is the formula that we're going to use, because what happens if the first term is 1, this number is just a 1, and the formula still works. So this will be the formula that we use every single time as we go through the rest of this particular chapter. G sub 1 is 1, it's still going to work out for us. All right, so let's use it. Suppose an ice cream store sold 22,000 ice cream cones in 2008. Based on sales data from the other stores in some of their locations, the manager predicts that the number of ice cream cones sold each year will increase by 5%. Use the formulas from the sum of the geometric sequence that we developed in problems 1 and 2. Find the total predicted number of ice cream cones sold during the period from 2008 to 2014. All right, so here's my first term, and that's going to be in 2008, and I want to keep finding terms up through 2014. So this one's a little bit tricky because we need to use our formula. We know what the first term is. We got to think about what's the r and what's the n. So here, I said you might want to write out the list so you see exactly how many terms there are. So we don't actually have to write out the numbers, but just think about how many terms am I going to have? So I would have 2008 and 9 and 2010 and 2011 and 12 and 13 and 14. So some of you may have thought there's going to be 6 terms because if you do a little subtraction, but remember we're counting the first term and we're counting the last term as well. So if you notice, there are actually 7 terms. So in this case, n is going to be 7. And then what's that common multiplier? What's that multiplier each time? Well, we're going to multiply, it's increasing by 5%, so we're going to multiply by 1.05. So there's going to be our r number. And then g sub 1 is how many there were that first year. So that's going to be 22,000. So I plug those into the formula. First term, r to the how many terms there are, minus 1 over r minus 1. Again, make sure that we put parentheses around that and around that and around that. And when we enter it in, we end up with approximately 179,124 ice cream cones. So a little bit of a trick here. Make sure that you know how many terms there are. Make sure you can find the R value, and make sure that we can quickly find that first term as we go through. All right, summarizing. Write a recursive and explicit function or formula for the sequence. If it's geometric, so geometric, remember we're going to have a constant multiplier. So my first term is my first term. To find my g sub n term, I take my term before it, which is g sub n minus 1, and then times r, times that constant ratio. And then explicit rule, so that's just going to be our exponential. G sub n equals, using the first term, it's g sub 1 times r to the n minus 1. So there would be our geometric formula. For the sum, there's our sum formula that we generated back on number 2, part E. So S sub n equals the first term times r to the number of terms there are, minus 1, over r minus 1. So that'll be the formula that we use. That would be on our formula bank as we continue on. So an expression showing the terms of the sequence added together is called a series. For example, arithmetic one, a sub 0, a plus a sub 1 plus a sub 2. And we can do the same thing with b's, are examples of series. A series is called an arithmetic series or geometric series depending on whether the sequence that generates the terms is arithmetic or geometric. The terms, the words, sequence and series have very specific meanings in mathematics, which might be different than their English meanings. So make sure you understand sequence means just listing the numbers, and series means we're going to add those numbers up. Thanks, and that was activity 4.